Hi everyone, and welcome to the second of 4 videos going through some past exam questions on transition metal complexes. This question is all based around platin, which is a complex that you do need to be aware of and know a little bit about. So it gives you the formula here, and it says a complex of platinum 2 that has 2 stereoisomers. One of these stereoisomers is used in medicine. Okay, it's going to ask us about that later on. It says platin is a neutral complex. Explain why platin is neutral. Okay. So the reason for that then is we know it's platinum 2, so we can say platinum has a charge of 2 plus. The NH3, the ammonia, is a neutral ligand. That has no charge. And the chloride has a charge of minus. I think that's all we need to write, really. Perhaps we should say, so the 2 plus charge of platinum and the 2 Cl minus cancel out. So that's a slightly odd question there, but not too bad. Right, draw diagrams of the 2 stereoisomers of platin. Now I told us it's got 2 stereoisomers here. So it's got this platinum, it's got 2 ammonia ligands and 2 chloride ions as ligands. So here, again, this should just be one that you need to know about. It's slightly unusual, this one, and it has this square planar geometry. Okay, normally if it's got 4 ligands, you'd expect it to be tetrahedral, but it's not. Okay, and it's just one that you want to be familiar with, really. So what we've got is platinum, and we've got, we can put 2 chlorine ligands on, and we can have the 2 ammonia ligands. Okay, this is how you'd represent the square planar geometry. It's the same as octahedral, essentially, but without the one at the top and the one at the bottom. Okay, so this is what we're going to have here is cis and trans isomers. Okay, this is a cis isomer because the 2 chlorines are at 90 degrees to each other. So the trans isomer would be, if I leave one chlorine where it was, but move the other one, so we're going to have an NH3 here, and then we want the other chlorine ligand to be at 180 degrees, so it needs to be in this position, not this position. Okay, the other chlorine ligand would be there, and the other ammonia ligand would be over here. That's going to be the trans isomer. Okay, and it doesn't tell you it's cis and trans isomers, so you don't need to have labelled them as cis and trans, but again, it doesn't do any harm. Let's get in the habit of getting comfortable with them. But it does say make sure you're careful with reading the question here, because it's very easy to move on. So draw diagrams of the 2 stereoisomers and describe its bonding. Okay, so we need to do that as well, because we haven't done any describing. Okay, all we need to say about the bonding is that the ligands donate a lone pair of electrons to the platinum ion to form coordinate bonds. And that's all we need. We don't need a huge amount. It's only going to be 1 mark here. You're going to get 2 marks for the 2 diagrams, so we don't need to write loads, but we do need to write something there. Okay. Right, and then we do need to know a little bit about this. It does actually crop up. It's on the specification that you are expected to know a little bit about platin, and it's used in the treatment of cancer patients. Okay, specifically it's cisplatin, not transplatin. But all you need to say, again, it's only 1 mark, so again, you don't need a huge amount of detail. But what happens is that platin binds to DNA and prevents the cancer cells from replicating. Because that's the problem, right? With cancer, it's uncontrolled cell division. Your cells are dividing when they shouldn't be. So by binding to the DNA, it can stop that from happening, because it can't replicate the DNA, and then it can't replicate the cell. Okay. Moving on. It then says, the use of platin in medicine can cause unpleasant side effects. In the search for alternatives, chemists often start with the current drug and modify its properties by chemically changing some of the groups. And it is quite interesting, right? Because we don't really talk about this a lot, but this sort of gives you a bit of an insight into what actual chemists are doing, right? So, right, we know this thing works. Can we make it better somehow? Well, let's start with that and just tweak it a bit. So a recent discovery is a drug called Carboplatin. The structure of Carboplatin is similar to platin that we've just done, except that a single 1,1 cyclobutane dicarboxylate ion, it's a mouthful, replaces the two chloride ligands. Okay, draw the structures of this. Okay, so what is this? It looks horrendous, doesn't it? But if we break this down, 1,1 cyclobutane dicarboxylate. Okay, well, cyclobutane, okay, that's just going to be 4 carbons in a ring, right, or a square. Then basically, if we do this, it just says draw the structure, right? So we can draw this in, whatever structure we choose. Let's do it in skeletal formula because that's simplest. So that's your cyclobutane, 4 carbons in a ring. So it's 1,1 cyclobutane dicarboxylate, right? So we've done the cyclobutane part of it. What's this dicarboxylate? Well, the carboxylate is the ion of a carboxylic acid, right? That's what a carboxylate is. So if it's dicarboxylate, there's 2 of those. And if it's 1,1, then they're both attached to the same carbon. So we're going to have this coming off here. Again, I'll keep it in skeletal formula. And then we're also going to have another one coming off of here as well. I'll just draw that the other way around just so it fits on a bit nicer. Okay. So that's it. That's our 1,1 cyclobutane dicarboxylate. Okay. And then, so what's the structure of carboplatin? So it then says that this ion replaces the 2 chloride ligands in the structure. Okay. So if we look here, this again shows you what it's saying. They didn't mention it here. They've just said platin, but I mentioned it a minute ago. I was saying, it's specifically cisplatin. And now you can see why, right? Because these 2 are next to each other. We're not going to be able to put these 2 ligands on across 180 degrees from each other. They're going to have to go on in the cis isomer. So we're going to copy this out and replace the 2 chlorines with this ligand instead. Okay. So let's have our let's copy this. So we're going to have the platinum with the 2 NH3 ligands in these positions. And then in these 2 positions, we're going to have these oxygen atoms from here. Okay, and now I'm going to have to be a little bit careful with how I join this up. I'm just going to actually spin this around and go, right, here's my carboxylic acid. And here's my other carboxylic acid. And those are going to, I've not made a very good job of drawing this. Those are going to have to be bonded to the same carbon, right? And then have a cyclobutane on there. Right, that's a complete mess. I might have another go at drawing that. If this was on my exam, I'm not going to leave it like that, right? That's a bit of a mess. So it might be better if I draw this out. It might be better actually if I just flip this around and draw this bit first. So let's have my cyclobutane and have my carboxylic acid there and there. And those could both be bonding to my platinum and have my 2 NH3 ligands coming off here. That looks a bit better. Okay. So awkward to draw, but yeah, that's what it should look like.